Hello, this is Professor Carter. This is the fifth video in the exposition of the neoclassical theory of production and distribution. In the last video, we considered the properties of the well-behaved production function, where the well-behaved production function is going to be defined as a production function that exhibits diminishing marginal productivity of the factor inputs. There we saw that the diminishing marginal product of labor, diminishing marginal product of capital, come together to create the well-behaved production surface. And this well-behaved production surface allows us to then conceive of different techniques. So the production surface is a technology, and the well-behaved production technology or production surface allows us to conceive of different combinations of capital and labor that yield the same output. The different techniques of production they're going to yield the same output. If you increase the scale of those inputs, it's going to increase the quantity of the output that the technology is going to be associated with the well-behaved character of the production function and the technique, the particular combination of capital and labor that yields a particular level of output. An isoquant is defined as a combination or a locus of different techniques, different ratios of capital and labor that is going to yield the same output. So it's going to be a constant slice out of the production surface. When we look at that in terms of factor space, we have our isoquant, we have the different techniques, the labor, the capital intensive technique alpha, the labor intensive technique beta. We arrive at the idea of the marginal rate of technical substitution as defined as the movement along the isoquant where we give up a certain quantity of capital in exchange for a certain quantity of labor, such that the change in the output is zero. That becomes the marginal rate of technical substitution. That becomes the slope of the isoquant. Here we express our capital and labor intensive techniques, and then with the isoquant map, we know that as we move up to the northeastern corner, we're going to move up the rising hill of output, and we're going to get more output, right? Now what we're going to be doing here is we're going to be looking at the other side of the producer equilibrium. So we have here, we define producer equilibrium as a choice of technique. This tells us that to produce a certain quantity of output, right, and make sure this is going to be constant, to produce a certain quantity of constant output, you have a different variety of different techniques according to the production function technologies that we're assuming. You have a variety of different techniques from which you can use to produce that particular level of technology. The question becomes, what is the technique that the producer will choose? Now here the assumption is made that the behavior of the producer is going to be exactly the same as the behavior of the consumer. Namely, it's going to be a constraint optimizing framework. The way I'm expressing it here is going to be the minimization of cost, the maximum output at the minimum cost. But for our purposes here, what we're doing is we're looking at the idea of producer equilibrium. We define that producer equilibrium as the choice of technique, and what we do with any equilibrium is we bring two functional relations into equality with each other. The first one is going to be the production function side, and this is what we were looking at in the last lesson. All right, production function side, this is going to be the marginal rate of technical substitution capital for labor, which we know is going to be equal to the ratio of marginal productivities, is equal to the marginal product of labor over the marginal product of capital. That's going to be equal to, this is going to be the cost of production side. All right, this is what we're going to be developing in this and the subsequent videos, the cost of production side of this equilibrium. This is going to then say that the marginal rate of technical substitution on the production side is going to be equal to the ratio of factor inputs on the on the cost side, where W is going to be equal to the price of labor. All right, price of labor, and then PK star is going to be the price of capital. Really, it's the remuneration to labor and the remuneration to capital. We'll talk about that, and that's what we're going to do right now when we introduce the cost of production. All right, so this becomes here 4. This is the cost of production. All right, and then the cost of production, we're going to be looking at the cost of production side of the producer equilibrium, right? I'll call this one here 4.1, page 4.1. Okay, so we define our total costs. Okay, so this is going to be the total cost of our production function. All right, so we have here our total costs. All right, the total costs are going to be equal to the cost of the capital input, okay, and you're going to add that to plus the cost of the labor input, which is going to be there, okay? So the total cost is going to be TC, all right, TC, all right, and that's going to be equal to, you're going to have the price of the capital, okay, going to be price per unit capital is going to be PK star. I'm going to talk about what that star represents, times the quantity of capital, okay, you can think of it as a physical unit, dollar per unit K times so many units of K. Not stressing a lot on that. We're going to come back to these issues when we look at the matter of the Cambridge controversies. Plus the wage rate times the quantity of labor. All right, and so what you have here then is going to be this is going to be dollar per unit K. This is going to be equal to so many units of K. The K cancels out. When you multiply it, that gives you so many dollars spent on the expenditure of capital. This in the wage side is dollars per unit L times so many units of L. The L cancels out. This is going to be equal to the quantity of dollars on the wage expenditure. So the capital cost plus the wage costs are going to be equal to the total costs, okay? That's going to be the cost constraint. It's going to be the budget line on the producer side. Now, let me introduce this PK star, okay? This PK star, there's a star attached on this thing, okay? Because really what this is going to be a remunerative price, okay? It's going to represent a normal rate of remuneration to the factor capital, the so-called normal rate of profit. So we say here where P star K, okay, the price of the capital input is going to be equal to, we'll call this PK without a star. You can think of that as the investment price or the cost price of the capital input, and you multiply that by 1 plus R star. Okay, where R star by definition is going to be the normal rate of profit. Okay, define quote unquote normal rate of profit. Now, what determines normality? That's a different question. It's a question we're going to enter and we're going to look up as the course develops, especially when we look at heterodox theories, etc. We're going to see there's different ideas of what we mean by normality. It's so too for the orthodox theory, but this is going to be the normal profit rate. All right, so this is going to be the normal profit rate. All right, so that normal profit rate is going to be included in cost. That's the point. Okay, so that means here that the cost of capital, we can think of it as a command price of capital. It's going to be the investment price plus the remuneration is going to be equal to, when you go ahead and effectuate the multiplication, PK times 1 is equal to PK. PK times R star is going to be R star PK. Okay, and so this R star PK here, this is going to be the remuneration to capital, to the capital input. All right, the distribution. And we call that the normal remuneration to the capital input. Okay, well, what do we mean by normal? Well, normal, you can think of it as just the regulating, if you will. There's different theories to determine normality, so that the normal rate of profit is going to be a certain quantity. Determine how is a separate issue we're going to look at. But the point is that if you have profit that's above the normal, this is going to be what we call extra profit. All right, extra profit, or it's referred to in economic theory as economic profit. Economic profit. When you're looking at your perfectly competitive model and the micro approach, you'll have economic profit. That's going to be profit over and above the normal profit, which means that if you have a profit that's going to be below it, all right, so then you have a profit below the normal, that's going to be referred to as economic losses. All right, where economic losses can, by definition, be equal to positive accounting profit. So we have here the idea that within the model there is a structure of normality, and the normality is going to be a assumption that we're assuming within the profit rate such that the price of capital that's entered into the total cost is going to include that normal rate of return. So that P star K is going to be the remunerative price of 1 plus the average rate of profit. Okay, and we'll talk about that. To develop this in the next